Hello, geometry genius or geniuses. If there are many of you watching this together at a party, maybe you want to put me on YouTube, put me on Apple TV, stream, whatever you want. Cool, whatever. With 7.1, we're going to be talking about ratios and proportions. A little bit of vocab here, nothing you can't handle. Probably some terms you've seen before, but I just want to talk about them so that we can move through this section and be speaking the same language. So a basic ratio is considered a comparison. So we're comparing, seeing what other ratios are doing, or quantities. So it's a comparison of two quantities using division, like so. You could do miles per hour. That's a pretty common one. Some of us are driving, I'm sure, and you're always curious if you're speeding or not, so that's kind of a ratio. You could do, what else? Distance over time. I'm sure you can think of some other ones. If you think of any good ones, let me know. As we continue to talk about proportion, this is really just an equation comparing two ratios now that are equal. And we see some examples of this in the following. The main hint here is that when we see a proportion, we see an equal sign, like so. We're going to solve these by cross multiplying. So we'll deal with fractions here. That's nothing we can't handle. I promise the fraction work here is nothing too crazy. So we'll see what's going on with this. Pause this for a second. If you want to try out some of these on your own, go for it. But I'm going to talk through, let's see, A and B, maybe D. We'll see. Let's start with A first. We have a proportion, and I know this because these are two ratios set equal to each other. So that makes sense. We can solve this by cross multiplying. So 4 times 7 will get us 28. Feeling great at 28. This is equal to the product of this denominator and this numerator. So 5 times x is 5x. And then we're pretty much in the direction of being done. We can then divide both sides by 5 to solve for x, because that's our goal. Remember, we're trying to solve. If we do that, this is claiming that x is going to be equal to 28 over 5. The important thing here is that we were trying to find this denominator, and if we were to plug this back in, this would make a proportion, because then these would be equal to each other, those two fractions. Pretty simple with that. As we hype up our denominators, a classic. As we hype up our denominators a little bit more, we can take the product of 3 and x, so 3x. This is now equal to the product of 2 with now x plus 2. Use parentheses here, don't get lazy. We can distribute the 2 in, getting us 2x plus 4. This equals 3x. If we move our x terms to one side, this is claiming that x should be equal to 4. Pretty simple, right? Just cross multiplying, nothing crazy. With this scenario, we have now x and y with a fraction of 4 halves in the middle. This should be simplified, but who's checking? Am I right? If we're focusing just on x, we can cross multiply that, get 12x equals 12, x equals 1. Super easy, super easy. Then we cross multiply for y. Get 4y equals the product of 12 and 16. So what's that going to be? 192? Is that right? If we divide both sides by 4, 4's can cancel. This is going to claim that y is equal to 48. Feeling great at 48. I hope I am. Nothing too tricky here. How about some word problems? You up for those? Does that sound okay? One problem that comes up a ton that I definitely want to talk about is with this vague triangle seen here. In this triangle, there's a ratio of the measure of 3 angles, 2 to 5 to 8. So this is another way that ratios or proportions may be written. Find the measure of each angle in the triangle. Well, I'm a visual learner. I don't know about you, but I'm going to draw this out. It doesn't have to be super crazy. But let's say that this would be the 2x. This side's the biggest, so let's put 8x here, 5x here. And the reason that we can rewrite this scenario here using now x is that no matter what x is, we're going to have to amplify this by 2 and then by 5 and then by 8. So whatever x is, doesn't really matter. The setup is super important, knowing that chances are if you see a setup with 3 angles or 3 sides claiming it's all equal to something, you can plug in x, use that, then go from there. I know this is a triangle, so I know that these 3 angles should add up to 180. So let's make a note of that. Okay, so I'm combining 3 angles. I know that should equal 180 degrees. I can then combine like terms here. So this is claiming 15x equals 180. If we divide by 15, this is going to claim that x equals, well, that'd be 12. That's cool. So now to plug in. So I know that this is going to be 2 versions of x. So 2 times 12 is going to be 24 degrees. 5 times that 12 equals 60 degrees. 8 times that 12, 96 degrees. Nice warm day, 96 degrees. Very cool. Notice if we were going to add these 3 up, these would get us back to 180 degrees, which is what we want. I hope this video was helpful. There are some other examples that we'll talk about in class. If you have any questions, bring them. Thanks for watching.